Well, it's that time of year again. Oh, no, not that time of year. Not just yet. It's time for exams. And I don't know about you guys, but there's always that one class that's just, like, evil. Well, this year that's most definitely physics. And for any of you that may not take physics, it's basically the study of every little freaking thing on the planet. And it's enough to drive you crazy. I mean, it's like consumed my life, looking at everything and trying to figure out what's the velocity or this. It's ridiculous. And it's going to send me to an early grave. Alright, so what's the next problem?
89, right?
Yeah.
Okay, I'll read it. A 100 Newton weight sitting on the floor is tied to a light rope that passes over a very light frictionless pulley 20 meters above it. The other end of the rope hangs down to the floor where it is being held by a 10 Newton monkey named George. Suppose George now climbs 10 meters above the floor. A. How much work does he do, both internal and external? B. How much rope ends up on the floor? C. What is the total change in gravitational potential energy of the system?
I can't do this. This physics is killing me!
Greg, calm yourself.
A monkey named George? What the crap?
It's the stupid physics book, okay? It's fine. Okay, we'll ask Mr. Bishop tomorrow if we don't get an answer.
No, Josh, there's not enough time. The homework's due tomorrow. We don't have time. There's too many questions. We can't ask Mr. Bishop tomorrow. He won't be ready to ask us tomorrow. He'll get into class really late, and we won't have time to ask him any questions. We'll have to turn in the homework late. We'll lose points. My grade will go down. I can't do it!
Greg, I think we need to take a break.
You're right, Andrea. This is a good idea to just get out into the open air. It's nice to be out here in the fresh air. The birds all around us.
I know. I love the fall weather. You got the leaves. It looks so nice. Cool temperatures.
Look at that beautiful tree.
That car's not going 25 miles an hour.
I wonder what its speed really was.
Well, if we calculate its relative speed from that mailbox to that mailbox, I don't know. What, 4 seconds?
No, we're not doing this.
Doing what?
We're learning physics to practically everything we do. Remember, we're taking a break.
Sorry.
Sorry.
It's fine. Let's just try to get our minds off of physics, okay?
Fine.
So, Josh, what are you doing for Christmas?
You know,
Look at that vulture circling overhead of us. It's going pretty fast. In for the kill.
Well, Andrea, it's not really going that fast. It's just so far away, it makes it look faster than it is. It's simple time dilation.
Josh, Andrea, we are not doing this, remember? Oh! That's, sounds pretty high, Josh. I want to be careful, I don't want to lose it.
It's probably due to the hard surface that the ball's bouncing off of, and then it gives it more momentum, due to Newton's third law.
What? Is it because of the reaction force? Because if you keep this up, you're not going to like the reaction force I'm going to give you. And you, mister, let's calculate the speed of everything. It's the velocity. We're dealing with displacement here. And vectors. Oh!
Cheers, George.
Where have you guys been? You understand the gravity of the situation? Your mother's really upset. She's gone off on a tangent.
Don't talk to us about tangents.
What number were we on?
I think 89.